for you. You give us the indoor floor plates, the capacities associated with that, and we'll give you the calculations for each iteration. You can tell me, I want to look at 36 ton, the biggest we've got. We know it's going to be fewer risers, simpler to install. We know it's going to operate fine, higher diversities. We can work around that, and we can, you know, play around with those combination ratios. Or I want to go just with a 12-ton system and just have it on a single outdoor unit, very straightforward. Okay. Bearing in mind we've got billing, so full indoor unit, individual tenant billing associated with our system. So that's why we're using it on a residential basis. So it's not prorated to per square footage or anything like that. It's actual consumption-based billing. But we'll get to that when we get to the controls. Okay. All right, we're going to run. All right, so when we look at design considerations for this, the spaced out obviously is critically important. Understanding where you're going to put the indoor units, how you're going to put them, where you're going to put the MS box, understanding what's associated with that is very important. Now, these, I've got the quick reference guide there of our VRF system that will give you an idea of the dimensions of the units. That is actually our phase 1 equipment. We're already in our phase 2 equipment. It was released at the beginning of this year. The dimensions are exactly the same. We've just upped the ante with regards to our external static pressure capability of the unit. So higher airflows, higher external static, but apart from that, the unit is exactly the same. There's no difference associated with that. So I've got 3 here for you. I've got 3 of our rooftops. So I've got the Landmark and the Energens, gas-fired electric heat pump, and then I've got the VRF quick reference guide there for you guys. And on the back end of that, you've got the piping limitations, the outdoor unit ranges, all of that associated work is on the back end of that. So it's a very quick way of getting around the information.
Also, Aaron just completed a spreadsheet of all the rooftop units that meet Washington State energy codes. If you want to have that, we can email it to you.
Yeah. Are your condensed units, are they only air cooled, or do you have a water cooled version as well?
No, they're only air cooled.
Okay.
We actually had a look at. Remember, we were developing this ourselves, so we don't have all the accessories that our competition has. We didn't just click them out of a catalog, right? So we looked at the cost of producing and testing and working with the water source system. Bearing in mind, Lennox, we're not water guys. We don't produce chillers, right? We don't want to mess with stuff we know very little about. For us to develop a water source system, we would have to open a whole water department, which we're not going to do. So that tied to the fact that there's been, as an incremental increase in air-cooled systems, there's been a steady decrease in water-cooled systems used. And that's really tied to that fact. If we produce one now, we would be lucky to sell one water-cooled system a year. There's obviously no payback there. So it's just scrapped by research and development team right there. Okay. So initial cost of the system is items to consider. That's actually an old line item. That should be the opposite. When I did, we were asked by a developer, a large developer in BC, to do some comparative pricing between hybrid heat pump, 4-pipe, water source heat pumps, and VRF. Between those 3 types of systems to see what the cost comparisons are as a whole, because you've got to take the plumbing into account, you've got to take the electrical into account, you've got to take all of these factors into account. And what we found, we were between 7 and 10% cheaper with VRF air cooled. Even though there are more copper piping going into that riser, the fact of the matter is very simple. Those massive water pipes that you're taking up and down, they're also extremely expensive and difficult to install. We didn't do that calculation. I partnered with a contractor who was predominantly known for water source systems, but he had also done 3 VRF towers. So we evaluated 10 different existing projects. I laid out the VRF for all the other ones, and he did the work back. So we had 10 VRF towers basically priced out, 10 water source of the one type, and 10 of the other type. And that's how we came to that per square footage per door and a total percentage saving. All right, so we've done the calculations. We know air-cooled VRF, if it's designed properly, it's going to be cheaper. And that was based on the most expensive system on the market. That was not based on my price. So that's really something to consider. Okay. The efficiency of the system, I mean, heat recovery speaks for itself. That's why you have it. So you've got that recovery where you need it. Not cycling it back up, trying to reuse it elsewhere or in a different state. Okay, so that is directly taken from the space, recovered and used on another system in that same system. So you can have 2 offices, one in heating, one in cooling, and that's really where the recovery happens, where you want it to happen. Okay. Heat pump or heat recovery. Now our heat pump is a 2-pipe system, no MS boxes. You go ahead, put the indoor units in, but it's going to do either heating or cooling. It will not do both simultaneously. Okay, so just bear that in mind. This has got selective application or applicability to applications, I would call it. I've personally ran into issues by selling a heat pump system as a cheaper option to heat recovery, and I'll never do that again. As a consultant, because I had to go back to that client 2 years after the fact. The developer would call me because I'm the engineer. They've dealt with the contractor says, well, that's the system you guys put in. Don't talk to me, I didn't design it. I had to go into site, speak to the developer. They read up VRF. Oh, it's heating, cooling, it's full simultaneous. He forgot about the fact that I told him that it's either or. And it's one thing to say, I told you. It's another thing in practice for him to try and explain to his employees that you're either going to get cooling and heating if one is, for example, in this case, was a very old lady and a very young gentleman. And they have two different, climate requirements. One gets extremely cold very quickly, and the other one, wants it colder and colder. So in that shoulder season, you can't give them both what they want. Okay, so just bear that in mind when you're doing a heat pump system. It's really for open plan spaces, CRU spaces, spaces where you've got a single load profile. Vertical doesn't really work very well with regards to that, at least not anymore, with a heat pump. Heat recovery is a 3-pipe system to the MS box, and from the MS box to the indoor unit is 2-pipe. Okay. So we don't have the big pipe system like our Red Team compatriot with a 2-pipe. Interesting fact, their patent on that 2-pipe system was actually expired at the beginning of this year. And not one other manufacturer has picked that up and tried to run with it. Because very simply, there's a reason why the 3-pipe system works so well. It allows better balancing of the systems and so on and so forth. You also don't have a proverbial tank you're putting into your seating void space. Because that thing's 14 inches deep and it weighs a lot. In most instances, it's more expensive than the outdoor unit. So that's also a few things to consider. That's why we're not doing a 2-pipe. We're happy with our 3-pipe solution. All right, typical VRF application. You guys have obviously done VRF, so you know more or less what application to use this for. Whether it's, this is a school application where you've got different, orientations. This would be a shoulder season area, or early morning, late afternoon, that sort of scenario. We have sun exposure on this end. You have shading on the back end. It's not an overly hot day, but there is that shift. One requires heating and one requires cooling. That's where the heat recovery really plays well. I've shown indoor units on these, but this, after looking at that and discussing it a bit more with some of my compatriots, I think that a better solution here would probably be a large-scale ducted unit, high static, for example, or a rooftop package unit. Because very simply, for a school application, for example, you've got a high amount of fresh air that's got to come in there. You've got to deal with all that. And a rooftop unit, ton per ton, is by far the least expensive system you're going to put in. It may not be as close controlled as the VRF system. It may not be as energy efficient, but it is still a good solution and it will do the job properly. It's another thing to consider when you're looking at fresh air for these systems. Why not use a rooftop package unit? A lot of guys will say, oh, we need to use a DOAS, or makeup air unit. DOAS and makeup air units are really there for close control of fresh air supply. When you're feeding into the back of a fan coil unit, that fan coil unit doesn't mind if there's a temperature swing of 3 or 4 degrees. It's not concerned about that, because it's going to operate accordingly. It's such a small volume that goes into that fan coil unit. So as opposed to spending $3,500 per ton on a makeup air unit, you spend it, $1,700, $1,800 per ton, maybe even a lot less, depending on what you need, for a rooftop package unit. And you get cooling as a standard. The reason why it's so high is because it has to be our Energens with humiditrol and an economizer and so on and so on. So all the extras get added on. So that's something to consider. Low cost solution for a problem like this, for a system like this. Why go to the expense of putting in a makeup air unit that can only heat? And if you want cooling, you've got to add a secondary cooling system that's normally not innate to that unit. All right, so that's just something to consider.
Are you saying that in lieu of a VRF system?
No, rooftop with a VRF system. So you use that as your makeup air unit, basically, a rooftop package
Okay.
unit.
Well, our energy quotient required the DOAS after, it does now, and then after buy it next year, it will be prescriptive, DOAS.
Yeah, so I think, part of that is, on that, there's two things. One is, still the rooftop package unit, which is a simple ERV, fan, filters. So you try to do that ventilation portion
Okay.
down dirty, and then that package rooftop unit that's gonna meet Washington State Energy Code, which can be a landmark or an Energins. I think that's what he's talking about with one just kind of big rooftop unit and the gymnasium kind of application,
Mm.
right? Versus trying to have a VRF serve that big large space, so that might play a factor in there. Then there's also, I believe, this is actually newer to me, I don't know if you and Scott were working on this, but you can have the rooftop package units go down to a ventilation CFM only speed. So it always does the ventilation and then it cycles on and off for heating and cooling on that as well. So then you might be able to actually get rid of the decoupled ventilation portion of it and still meet the energy code on there. I gotta look a little bit more into that because that was some news to me earlier this week on there.
Yeah. So, all right, so designing for diversity on a VRF system, because we're looking at point loads and because we're addressing load where it exists as opposed to blanketly producing load or taking care of load on a floor by floor or large scale basis, we need to look at occupants, we need to look at building layout, all these things you know about. You guys have been doing it way longer than I have, so you know about that. But what's interesting is how you zone a VRF system. We try and zone as much internal and external together as we can for that heat recovery benefit associated with that. Because your MS boxes that are located here are going to give either free heating or free cooling depending on what the call for that is. So that really is a big benefit when it comes to heat recovery, and that's why we do it. That's why we talk about trying to put it on a full plate and put that plate on a system, or a couple of floors but a full plate. So you get the benefits of having the shaded and the sun exposure area on the same system, because you get that interchange of energy. It allows you to go higher on a combination ratio standpoint. It allows you to make sure that you effectively produce and meet load and know that you always have something on the back end, and that heat recovery is always going to take care of you with regards to that. It's very simple to do, it's easy to do, but it's a big benefit, especially from an energy consumption standpoint for clients. Okay. All right, let's get into product. Okay, so we've got outdoor units, indoor units, and controls, and MS boxes. Now, in the past, until about an hour and a half ago, we had only a 3 and a 4 ton mini VRF. This morning we got told that the VRF 5 ton has been released to me. It'll be released to our ACI members in 2 or 3 weeks, I believe, the full formal release of it. But it is there, it's here. We can use it.
And that's heat pump only?
Heat pump only, yeah. Single phase, so it has got its application, but it's a true 5 ton. It's not a 4.5 ton we're marketing as a 5 ton, it's a true 5 ton. And we can connect up to 6.5 ton internal connective indoor units onto that 5 ton. So that's really quite cool. Indoor units, we've got the whole range. Alright, so there's nothing strange about that. You've had this presentation from all the different manufacturers. We've got the vertical air handler, we've got the ducted units, medium static ducted units, high static ducted units. In fact, we've got the highest external static on any of our competitors on the high static side. So it's a serious unit that can do a lot of airflow on the 8 ton model. We've got a 2x2 cassette and a 3x3 cassette, the wall mount. So we really have a big range associated with that. And controls we're going to get into a little more deeply, because I know that's where you either win or lose the VRF battle. Okay. So our outdoor unit, the key features we have. Inverter scroll compressors, that's a standard for us. We don't compromise with that. Our 12 ton has got 2 inverter scroll compressors on there. Both of them are inverter. You don't take a chance. High performance energy exchanger, we're going to look at that in the next slide. That's quite cool. The multi-speed DC fan motors and the innovative fan blade design, and the service friendly. Having a look at this, it might not look like anything different from our competitors, but you'll notice it's easy to get to everything. Let me move on and I'll show you.
The DC fan motors, is that different from an EC, an electronically commutated motor?
No, it's really the same thing. They just call it something different. Sort of somewhere, just the way it is, right? Yeah, there's really no difference between the ECM and the DC motor.
Okay.
Heat recovery split coil. So our coil can actually operate in 2 different modes simultaneously, which means it can be in evaporative and condensing mode at the same time. And what that allows you to do is you have independent defrost. So that unit will keep running, and then one half of the coil will defrost. Bearing in mind, if you have 3 modules of these and only one half of one coil is in defrost mode, the likelihood is you're not going to have any drop in capacity, because very rarely do you take full advantage of all 3 of your compressors on a 3-module system. And even on a single module, that'll take a defrost cycle down to 4 minutes, as opposed to some of our competitors who has a 20-minute downtime. Okay, so that really is something to consider with regards to that. Also, what's
And that's
nice
4 minutes at half capacity or 4 minutes off?
at half capacity.
Yeah.
So that's also something to consider, right? Now, think about this. If something happens to one of those compressors, how difficult is it for our competition to do a switch over and allow that compressor to, or system to hobble along on a single compressor? For us, it's fairly simple to do because it's already separated in that sense. So it allows us to operate that system. If a compressor goes down, a quick field adjustment would allow you to run that system on 50% capacity while you wait for a new compressor to come. If a board fails, nothing I can do for you, sorry. There are mechanical equipment that will fail at some point. So, I mean, I don't want to naysay it, but a very wise man once told me, if it moves, it breaks. That's just the way it goes. The engineered fan blade design, you'll notice this one has 3 blades, that one has 4 blades. What that allows us to do is to make sure that there's no stacking of frequency, there's no harmonics that come into play here. What that means is we've got a lower noise production, and also eliminates phase pulsing associated with that. Right, so that's also something to consider, especially if you're putting this on a roof of a residential building, for example, with a penthouse has a nice big pool at the bottom. You don't really want the noise breakout from these to affect, the people swimming in their pool. Service-friendly design. Being Lennox, similar to our rooftop package units, we want to make sure that you can take anything out from there that you want and put anything back in easily, effectively, without spending 3 or 4 days getting a specialist inside and trying to rebuild your unit on site. Okay. Compressors are right in the front. Take a couple of bolts off, loosen the connection, take the compressor out, put a new compressor in. Easy as that. You don't have to cut pipe, remove pipe, do anything like that, like some of the competitors where you've got to do that. It's not designed for ease of manufacture. It's designed for ease of replacement after the fact if something does go wrong. Okay. Look at this. This is a hinged electrical panel. It allows you to fully hinge it open and get to anything you need to in the back. The electrical board on the front also has a hinge. Take 2 screws out and it hinges out of the way to get to the inverter board in the back. It allows you to get to everything without actually dismantling the whole system and the whole product. You guys are engineers, you're not going to have to do that, but your contractors and your client after the fact is really going to be happy with the fact that their service calls or their maintenance calls are not going to be as long. Okay. Combination ratio, 50 to 130%. We've talked about diversity, talked about connecting these systems together, so you can do multiple indoor units versus this one outdoor unit, up to 13 tons versus a 10 ton, or as low as 5 tons for that 10 ton unit. All right. Our temperature range, our heating operation goes down to minus 13 degrees Fahrenheit. So, that's we're never going to see that up here. Well, unless you're talking about Snoqualmie, but for the most part, here in Seattle, up in Vancouver, in Portland, you're not really going to have any worries with regards to temperature ranges here. You'll notice the simultaneous heating and cooling here. The reason why that's at 23 and not at minus 13 is the fact that it tries to balance itself out. I can't tell you it's simultaneous heating and cooling, it's going to do the full range. I don't believe any manufacturer can do that. Because very simply, that shoulder season range, when it goes into that cooling and then back into that heating, the cooling limit is still set at 23. And the heating limit might be set at minus 13, so it'll go down there and then the heat recovery will take place internally. It's not going to not do heat recovery. It's just stipulating that this is the sort of central overlapping simultaneous heating and cooling bracket. Okay, so bear that in mind. If it has to go into cooling, it'll only do cooling at 23. It's not hard stop there. That's just where it's selected at. It can go lower. It can go lower than minus 13. That's just where I select that for you. It's not going to do 100% capacity at minus 13F. That's just where I can select it to you for. So we have the D rates included in the system in our selection package, and I'll tell you what the actual capacity of the unit is at that temperature. Okay. We have the 3-phase options in 460 volt and 208 3-phase. Single module goes up to 12 ton. Then we've got combinations of that all the way up to 36 tons. All right. So we don't have the 40 something tons that some of the other guys have, but what we have, we know works, tested it, and we're developing. I know there's some new items that are in the horizon, and we'll get up there very soon. Now we have the 5 ton too, connecting up to 9 indoor units. All right. So that's really a good system to use, supplementing a small electrical room or a little office that you just heard about on the back end. There's no capacity on your big system. Put in a single phase system like this. Condominiums. There are a lot of projects where this really does work well. Okay. This only has down to 5 degrees though, 5 to 118. That is hard locked down there. It's going to shut off. The compressor is going to try and protect itself. The newer versions that we have coming out now, the 5 ton and subsequently the 3 and 4 ton, will come with an integrated base pan heater as standard. So that's going to allow it to defrost quicker. You don't have to worry about any auxiliary installations happening after the fact. It's supplied with that as a standard. Indoor units we discussed, so we're not going to go into that. Let's get into controls. I'm talking a lot. You guys still awake? Yeah. Any more questions? All right, this is where it gets interesting. The local controller we have is a programmable controller that was released at the beginning of this year. It's really one of our little shining stars, if you can call it that. We're happy about this because very simply, you can customize this the way you want. And you can do that from a developer standpoint. If you don't want them to have any control over these settings on top, you can hide it so that no one can adjust that. If you don't want them to be able to adjust fan speed, swing, room temp, schedule, either any one of those, you can go on the back end and hide it. Just give them this temperature up and down bar. How many times have you not seen or been called out to site where there's an issue, oh, the system's gone down, the contractor said, oh, it's not my problem, or whatever the case may be, developers complain. You go to site and it's an old lady playing finger roulette. They're trying to see, oh, they need heat, so they put it 86 degrees. Oh, they want cooling, they put it all the way down, right? It happens. And oh, the system doesn't work because of this and that. You can lock in temperature points, a high and low point on the back end where they can't see. Go into the settings menu up here, into the back end. It looks exactly like this. It's fully written out, so you don't have to push 7, 8 buttons together and hope that you got the right combination to get into the right selection screen. In this case, you go into the back end, you can adjust anything you want on there. Temperature ranges, recalibrate it. Recalibrating is an interesting one for me. When it was first brought out, you can recalibrate it on site. Where would you actually use that? Why is it not calibrated when it comes out from the factory? Very simply, how often do you not have to put that controller behind the door where it's out of the airstream? Where you would have to compensate what's actually happening in this space, what they're feeling on this end versus what they're feeling on that end. In this case, you can recalibrate it to suit that temperature difference, and you can play around with that to make sure that you're actually receiving and sensing the temperature that you should be sensing if you don't have a return air sensor or a space sensor associated with that. So you can recalibrate that and make sure that the system operates and works well. I was actually on a site the other day where they put one of those massive Konica Minolta printers right underneath the wall-mounted controller.
Of course.
That heat's just going right into that unit. That unit's never going out of cooling. In the middle of winter, it just kept cooling because that heat was just going right into the back of that sensor. And they didn't set it back to the return air sensor. So, things like that happen, and you've got to, take that into consideration. Scheduling, there's up to 7 actions a day, night setback mode, you can program all of that in. It doesn't come standard programmed with night setback because some areas do not require night setback. Canada being one of them. We don't have to provide a night setback mode. So therefore, why would we bring it out where it's innately built in? We want to give our clients the ability to adjust it as necessary. Okay, based on their requirements. So you can set that night setback in there. You can work everything there from what you want. It also has a built-in USB port. What that is good for is if you have 200 or 300 of these wall-mounted controllers in your building, to have a contractor go in and try and commission every single one of them will take them, a month and a half to do, because it's not going to be quick to set this whole system up the way a client wants it. A lot of times they've got a fixed way they want that set up with. In this case, you copy and paste, you set one up, you copy and paste it onto a USB, and you can change the settings as quickly as pasted. That's it, and it adjusts the whole setting of the system automatically. So it allows you to commission it much faster. So the contractors are really loving this controller. It also has an HHE kit, the dry contact. Unlike some of our competitors, this has 4 different contacts associated with that. So we say fan output, cooling, heating, and auxiliary heat. What that actually ties back to is this little controller of ours here. We can go into that settings menu, and I can tell that auxiliary heat, whether it's a baseboard heater, whether it's a duct heater, whether it's a ERV or an HRV. It can be anything you want, an exhaust fan you want interlocked with that. You can dictate that, for example, a baseboard. Up in Canada, we use that, or a duct heater. We're supplying that in those Saskatchewan, for example, we're supplying that. And what that allows them to do is, if the ambient condition drops below a certain temperature, it overrides the indoor operating mode of the fan coil unit and switches it automatically on that baseboard heater. It's a setting we can adjust on there. You can also control on indoor room temperature. If that room temperature starts to drop below that set point and the unit can't keep up, it'll bring that in as an auxiliary heat with the unit. You can set what that unit does. Do you want the indoor unit to run in fan mode while the duct heater is operational? Do you want it to switch off if it's a baseboard and not have that fan movement? You just want it to switch into fan mode, as I mentioned. So there's no competition, or I call it competition. There's no 2 modes running in the same space. There's no heating and cooling trying to compete with one another. So it's fully interlocked in that way. So that really is something different than what I've seen in the past. Right, now the touchscreen controller. This is our central controller. This is the sort of big daddy of our control system, if you could call it that. We can do up to 1,024 indoor units or 64 VRF